So now let's look at the next subtopic over here. So our next subtopic is about momentum. Okay, momentum. So the first point, linear momentum, product of mass and velocity. Okay, so that's the definitions of momentum, product of mass and linear and velocity. So the formula P equal to mv, mass times velocity. Okay, then we have the principle of conservation of linear momentum. When bodies in a system interact, total momentums remain constant. So the example is like when two bodies collide, the total momentums remains the same, provided no external force acts on the system. Okay, so let's say I give you an example. Two trolley collide. So after collisions, let's say after collisions, let's say the two trolley move in front. You go and count the momentum before collision, and then you go and count the momentum after collisions. You will realize their momentums are the same. Okay, so let's say I put value for you. Let's say for the first trolley, I call it MA, 1 kg. This one MB, 2 kg. This one I call it UA. Let's say I call it let's say I put 2 meter per second. For UB, since it's moving to the left, I put negative value, negative 1 meter per second. Okay, so after collision, let's say this is still 1 kg, the velocity. Okay, now let's say I have moving forward, right? So let's say 1 meter per second. Okay, this one MB, 2 kg. Okay, I need to change the value a bit. If not, it's not reasonable. This one, let's say I change it to 0.5 kg. Okay, then you can find out the VB. The VB, let's say I call it X meter per second. Okay, so how to find out? You can use this formula. This is the formula which is coming from the principle of conservation of linear momentum. So MAUA plus MBUB equal to MAVA plus MBVB. So if I use it here, MAUA plus MBUB equal to MAVA plus MBVB. So MA is 1, UA is 2, MB is 0.5, UB is -1, MA is 1, VA is 1, MB 2, VB X. Okay, so we can count the X based on the information here. Okay, I count the thing on the left. I get 1.5, 1 plus 2x. Then I will be able to get x. 1.5 minus 1 divided by 2 0.25. 0.25 2 minus 0.5 minus 1 divided by 2. Yeah, okay, 0.25. Okay, so that is how we use the principle of conservation of linear momentum to work out the VB. The VB. So you can see the concept here is the total momentum before collision is equal to total momentum after collision. Okay, so the idea is like that. Okay, now let's move on. We have other situation also. Okay, this is the not only the situation. We have other situations where the principle of conservation of linear momentum's formula is a little bit different. Okay, so our first case here, I call it elastic collision. Okay, elastic collision is where after collision they move separately. They move separately. So we call it elastic collision. So elastic collision, you can
This
just
case is elastic collision.
yes, this is elastic collision. As they move separately after collision, they move separately. Okay, so if they move together after collision,
Trouble understanding between elastic and inelastic. So elastic means they move separately.
yeah, they move separately after
How is
collision.
that?
Sorry.
How is that they move separately?
Imagine after collisions, this one and this one, they don't stick together. They have their own velocity, which are of different values. So from there we know they move separately. That is elastic collision. Yeah.
In the velocity part, they have different values. So from there, we will know that they are elastic collision.
Yes, correct. Their velocity will be different.
So can you also show me an example of inelastic collision?
In elastic collision will be like this. Okay, let's say I put it here. In elastic collision, so initially they move forward. Both of them move forward, let's say. So then they collide. After collisions, they move together. They move together. How can this happen? Let's say, for example, you put some plasticine at the back, so that when the trolley at the back collide with the trolley in front, they will stick together because you put something sticky there. You make them stick together. So in that case, this is inelastic collision. Okay, so for inelastic collision, you may still using MAUA plus MBUB equal to MAVA plus MBVB. You are still okay. It is still okay if you use this formula, where at the end you will find VA and VB are the same value. Okay, same value. VA and VB will be the same value. If you don't want to use this, then there is an alternative. MAUA MBUB equal to MA plus MB V. basically because they move together, they both have the same velocity. So we can imagine that VA and VB are the same value. So you can factorize the same value and put it out here. So you can use this formula also for inelastic collision. Okay. If you don't want to take, yeah, sorry.
Understand.
You understand, huh? Okay. So of course, if you don't want to take the second formula, you just take the first equation, where remember that VA and VB will be the same.
Okay.
Yeah. So we also have one more situation, where we call it explosion. Explosion is like, for example, the two trolleys stick together at the beginning. They stick together. So let's say you use a hammer to knock on the two trolley. So you knock here. So after you knock, then both trolley will move to each direction, in opposite direction. So this is what we call explosion. So after knocking, then they move separately.
Is it also like using a gun?
Yeah, same idea, using a gun. Initially, the gun and the bullet are together. So after that, they separate. So same idea. Okay. So in this case, if you use MAUA plus MBUB equal to MAVA plus MBVB, it works, but you have to remember that UA and UB will be the same value. UA and UB will be the same value. If they are not moving, UA, UB will be 0. Okay, so after you knock, they separate, and then they will have different velocity. VA and VB will be different. So if you don't want this, then the alternative is, since we know UA and UB are the same value, you can just factorize it like this, and then after that, after explosion, something like this, different velocity. So we have altogether 3 situations: elastic collision, inelastic collision, and explosion. Okay, 3 situations. So let's finish it first. After principle of conservation of linear momentum, we have impulse. So impulse is the product of force and time for which it acts. So you take the force, multiply with the time, then you get the impulse. Or you can also take mv minus mu to get the impulse. So there are 2 formulae to find out the impulse: ft or mv minus mu. So that is the 2 formula. Okay. Now I give you one example. Let's say this is the wall. So an example for impulse. You throw a ball to the wall, and let's say just before they knock the wall, the u is, let's say, 3 meters per second. So it knocks the wall and then rebounds. So let's say when it rebounds, the v is, let's say, 2.5 meter per second. 2.5. Okay. Now the thing is, you know velocity, right? Plus minus is important. Plus minus direction is important. So you have to set which one to be positive, which one to be negative. So you have to set that. Okay.
So the initial U will have to be positive.
That is fine actually. Okay. If you take U to be positive, then this will be negative. Okay. So you see, I put it in two situations. I assume here to be positive. Then my U is positive 3, my V is negative 2.5. The second situation I set here to be positive, left hand side to be positive. Then my U is negative 3, my V is positive 2.5. So I put two situations, then we discuss on this. Okay, let's say the ball is 2 kg. 2 kg. Okay, so let's count the impulse. So impulse, yeah.
The mass is always same.
You mean the mass?
Yeah.
Yeah.
The mass, is it always the same for the initial velocity and final velocity?
Yes, the mass will be the same.
Okay.
Yeah, you just knock on the wall, then the ball will still the same ball, so have the same mass. Okay, so you see mv minus mu. So 2 times negative 2.5 minus 2 times positive 3. So you get negative 5 minus 6, you get negative 11. Okay, negative 11. So the unit is Newton second. So this is the impulse. We get a negative value. Getting negative value is kind of reasonable because there are the wall that push the ball in a negative direction so that the ball rebounds. So the negative 11 Newton second is like the wall push the ball in the negative direction so that the ball rebounds and move to the left. So kind of reasonable. Okay, but the thing is, normally when we look at the mark scheme, right, there seems to prefer the final answer to be positive. Okay, so if you do more past year paper, you will realize so. There seems to prefer the final answer for impulse to be a positive value. So because of that, this way is something that you normally see in the mark scheme, so that you get a positive answer. So it's still mv minus mu. 2.5 minus 2 negative 3, then you get 5 plus 6, then you get 11 Newton second. So more popular, okay, to see something like this as the final answer in the mark scheme. 11 Newton second. Okay.
So that means the first working they will give wrong.
Nothing wrong actually. Okay, nothing wrong.
But they
Yeah.
mark wrong.
It's still correct one. It's just that I want to let you know first. If not, later when you learn this, then you look at the mark scheme, you feel like, how come the answer is positive? I count and get negative. Why the mark scheme show positive? Am I wrong or not? Actually, you are not wrong. It's just how you set your direction only. You're not wrong. So both are correct.
So I'm a bit confused with this. Can you repeat again, what I should, how I should make sure that the answer is exactly like the mark scheme?
Yeah. So the answer if your answer same in the mark scheme, that is the safest way, you know. So if you want to make sure your answer same with the mark scheme, so the way is you try to make the final answer to be positive, right? Okay, so what to do is, my suggestion, right, you do try and error, you know. You do try and error. If you set this direction to be positive, you count and get negative, right? That means you can just change direction. You quickly change direction, change it to opposite, and then you count, you get positive. Then you get answer same with the mark scheme. You know, you
So is
try.
there a
Yeah.
reason like why they don't like why we cannot put negative for the final exam? Because I feel like the final thing velocity it's going to the left, so
Then you
isn't
feel
it
like,
like appropriate to put negative?
yes. So this is very reasonable to be negative. Okay, so the final also negative, which is reasonable. It's just that the mark scheme like to put final answer as positive. So that's why you can adjust accordingly in this way.
So this is like a trial and error kind of questions lah.
Yes.
Okay.
Yeah. So here I show you both so that you just keep in mind first. Okay, we are going to practice now. Actually, we are going to practice, and you see how we handle it, and I will let you see the mark scheme also.
Okay.
Okay, so let's see. Figure 2.1 shows a dummy of mass 70 kg used in a crash test to investigate the safety of a new car. So they put a dummy here and then they do the test. Okay, so of course this is like a fake human. Okay, just to check on it, what happened to the dummy. Are they going to break, or is this dummy safe or not? So the car approaches a solid barrier at 20 meter per second. So this is the U. The U is just before collision. Just before. Okay, just before collision, you get a U. Okay, you get a U, and then it crashes into the barrier and stops suddenly. Okay, so calculate the momentum of the dummy immediately before the crash. So we have the same issue again. Since this car moved to the left, should I take U as negative 20? So you know in convention, right, the left is negative, the right is positive. So you may wonder on that also. So should I put U to be negative 20, or I just put U as 20? So let us discuss on this. U should be negative 20, or U is 20. So both will be correct one actually. Both methods are correct. Okay, so it is just that the mark scheme used to leave our final answer as a positive value. Okay, so let's see. Okay, I put in two different color. Okay, let's compare. Two different color. Then I let you see the mark scheme at the same time. So if I follow the red color, where I assume left hand side is negative, then my answer is going to be, okay, in red color, momentum equal to mu, the mass 70, momentum of the dummy, multiply with negative 20, then you get negative 1400. Newton second. If you don't want Newton second, you just put kg meter per second. Okay. This is the first possible answer. And then if I follow u to be 20, right? So P equal to mu, 70 times 20, 1400 Newton second, or kg meter per second. Okay. Now, which one should we take? Okay, I let you see.
The blue one.
The blue one, yes. They like to put the final answer as positive. Okay, so let's take a quick look. This question is taken from 2016, June 41. Okay, so IGCSE Physics. Two 2016. Paper June 41. Question 2. Okay, so as you can see here, positive as the final answer, 1400. 1400. Okay, so that's the thing. Okay, so the mark scheme show this. But I have to say that nothing wrong if you put this as the final answer. Okay, it's just that it's different from the mark scheme only. It's still correct. So what's the difference between this and this? The red one is where you assume right hand side to be positive. The blue one is where you assume left hand side to be positive. So that's the thing. Now we look at part 2. Determine the impulse that must be applied to the dummy to bring it to rest. Okay, so rest means 0. 0. So V equal to 0. V equal to 0. Okay, so again, there are two ways. So the first way is U equal to negative 20, V equal to 0. The second way is U equal to 20, V equal to 0. Okay, so we count the impulse. I show both. Impulse equal to mv minus mu, 70, 0, and then 70, the u, negative 20. Okay, so then you get 1400 kg meter per second. So you get something like this. Okay, mv minus mu, then you get something like this. Okay. Now if you follow the blue one, impulse equal to mv minus mu. Okay, so 70, 0, minus 70, 20. So seems like this time you get negative 1400. Okay, so now let's see what they give in the mark scheme. So again, 1400. Okay, so if you have negative 1400, it is still correct because they mention it here. Same numerical answer. They look at the number only, they don't care about the plus minus. Okay, so that means
They don't care about the sign.
yeah, they don't care about the sign, I know. So if you take left hand side as positive, right? So this one it seems like okay, match with the mark scheme. This one it seems like it doesn't match with the mark scheme. Okay. If you take right hand side to be positive, this one it doesn't match with the mark scheme. This one it matches with the mark scheme. So both are correct actually. Now it's just that the mark scheme used to take final answer to be positive. So if you get negative, it's still acceptable. Okay, now let's continue. Part B. In the crash test, the passenger compartment comes to rest in 0.20 seconds. Calculate the deceleration of the passenger compartment. Deceleration, so that means you have to use A equal to B minus U, yeah, over T. Okay, now again I show two working. One in my red color values where the V is 0, the U is negative 20, the T is 0.2. So you divide, then you will get positive 100. If you follow the blue one, the V is 0, the U is 20, the T is 0.2, negative 100. So again, the problem is, which one should we take?
The red one.
The red one, okay. Positive value. Actually, both will be acceptable. Both are acceptable.
It's deceleration, right? So
Deceleration. Sorry.
Because it's deceleration, so actually we have to take the blue one, right?
Logically yes. Logically
In
yes.
this case, so they prefer positive answer.
Yes, they prefer positive answer also. You see, at the end, 100. 100 prefer positive answer. Okay.
So in any cases where like they ask for anything, so positive answer is more preferable.
Yes, correct. Okay. So if you get negative, of course it is reasonable, then you just add a note. Like since negative means deceleration, so deceleration is no need negative 100 meter per second. Then after that,
in exam if I put deceleration equals to negative 100 meter per second square, then I won't be marked as wrong also, right?
you put negative 100.
Yeah, in exam.
Strictly speaking, we cannot have the negative there. Acceleration is negative 100, but if they ask for deceleration, we have to remove the negative. We have to remove the negative. Okay, yeah. Acceleration is negative 100, but deceleration is 100. We have to remove it. But the thing is,
Deceleration, isn't it going down, sir?
negative means going down, what it means.
So
Negative means slowing down. Slowing down.
deceleration means slowing down, which
Yes.
is also means negative 100.
Yes, negative 100. That is slowing down. Yeah, but deceleration, you remove the negative. Yeah. Okay. So, but no matter how,
They remove the negative because they don't want negative answer.
yeah, they don't want negative answer. That is one thing. The other thing is deceleration is already means slowing down. So no need to put the negative anymore. Yeah, so that is the thing which is confusing. But the thing is both are correct, both are correct. Okay, so no matter you follow the red one or the blue one at the end, the idea is both are correct. Okay, now let's move on. Part C. The seat belt and airbag bring the dummy to rest so that it does not hit the windscreen. The dummy has an average deceleration of 80 meter per second square. You see, this deceleration, right? No negative one. Because deceleration already means negative. Already mean negative, huh? Okay, so calculate the average resultant force applied to the dummy of mass 70 kg. Okay, so again, there are two possibilities for this. If deceleration is 80, that means my A acceleration is negative 80. Strictly speaking, supposed to be like this, So if deceleration is 80, then acceleration is negative 80. Or you just don't care and put 80. Don't care and put 80, yeah? Okay, now let's say I show both. I show both working. Newton's second law, F equal to ma. F equal to ma. Okay, then I just count. 70, negative 80, negative 5,600 Newton. Okay, so after that, if I follow the blue one, $70, 80, 5,600 Newton. Okay, so which one is correct? Again, the idea is they normally put final answer in positive. So 5,600. Is it positive answer again? Nothing wrong if it's negative 5,600. Nothing wrong. It's just that they prefer to put final answer as positive. Okay, nothing wrong. Somehow this is kind of reasonable to be negative. It's like the force act in the opposite way of the motion. Okay, to push the dummy to stop. Okay, so supposed to act in opposite way. But at the end both are acceptable lah. Okay, so the safest way is follow the mark scheme. If the examiner is maybe not paying attention, different answer, okay, I put wrong, then you are taking risk. Okay, you're taking risk for this case. Okay, now D. the deceleration of the dummy is less than the deceleration of the passenger compartment. Explain why this is of benefits for the safety of a passenger. Okay, so that means we have, let's say we have seat belt to hold the dummy so that the deceleration is smaller. Okay, so why this is good? So the first reason is, you know, if you see this part, the previous part.
So I still don't understand the statement, the deceleration of the dummy is less than the deceleration of the passenger compartment.
Let's say the passenger compartment means the car. The car, let's say, is deceleration of 100 meter per second square. 100, but the dummy is just 80 meter per second square. So why is the dummy is slowing, having a smaller deceleration is basically because the dummy has seat belt that slow down the change, that means decrease the deceleration. Their seat belt.
Okay.
But the car will just knock on the barrier straight away, without anything to make the deceleration smaller. So then they explain why this is of benefit.
Passenger compartment means the car itself.
Yes, the car. Passenger compartment is the car. Okay. So of course we can easily see from the formula to understand it. If the car have a greater deceleration, then 70 times 100, let's say, you should expect a greater force. Greater force. 70 times 100 is 7,000. Greater force. The passenger compartment will have a greater force. So then the dummy with smaller deceleration will have smaller force. So the first advantage is the force. Force on passenger is less. Okay, now what else? This is 2 marks question, so we put one more point. Passenger double S, passenger is less likely to get hurt. Okay, so this is how we handle the questions. So from here you already get some exam techniques. So this question we settled already.
Sir, can you please minimize the page so that I can take picture?
Okay, sure. Okay, so let us look at this question. This question is on page 14. Figure 2.1 shows 2 railway trucks on a track. So we have truck A of mass 6,000 kg is moving at 5.0 meter per second. It is approaching truck B of mass 5,000 kg, which is stationary. So again, when you see this situation, you may end up with this UB to be 0, this UA, because it moved to the left, you will put -5. Then they ask you to calculate the momentum of truck A. So momentum of truck A, P equal to MB, right? MB MB, yeah? For our case, MU. Okay, so 6,000 times negative 5.0, which is negative 30,000 kg meter per second. So you get this value. But again, if you look at the mark scheme, they put positive. They put positive. So in that case, if I follow the blue color one, I assume left hand side to be positive. Then my UA is positive 5, you know. So then P equal to MU 6,000 times 5, 30,000 kg meter per second. So the mark scheme put positive answer. Of course the mark scheme is with me, so I can easily see that. Okay, now let's continue. Part B. The trucks collide. Their buffer compress, and then they bounce off each other, remaining undamaged. Okay, bounce off each other. This is what we call the elastic collision. They don't stick together. They bounce off each other, so that means they move separately. So after the collision, truck B has a momentum of 27,000 kg meter per second. Determine the impulse applied to truck B. Impulse, huh? Okay. Now, Ft equal to mv minus mu. Okay. Now, this is the formula for impulse, and for our case here, Ft is not really applicable here because they don't give the time. We are given the time in part 2, as you can see there. So I just use impulse equal to mv minus mu straight away. So the Ft I don't want to use first. Okay. Now this is for truck B. As you know, truck B, the UB is 0. UB is 0. Okay, then VB we don't know. They don't give. Okay, and we know the MB is 5,000. It's 5,000. Okay, now we substitute and check what happened. Okay. Although we don't know VB, but we are still able to do it because after the collision, truck B has a momentum of 27,000. So this is MBVB. You know, momentum after collision is MBVB. So we have the MB actually, 27,000. Minus with 5,000 times 0. So which is 27,000 kg meter per second. Okay. Then we get the impulse now. We look at part 2. Okay, so the trucks are in contact for 0.60 seconds. Calculate the average force on truck B. So now we use Ft equal to mv minus mu. You want to count the force, you put the time. mv minus mu is count from the previous part, 27,000. Then 27,000 divided by 0.6, we get 45,000. So we get 45,000. Yeah. Then, of course, from this point onwards, I just don't care about the left or right as positive, negative already. I just want to get my final answer as positive answer. Okay, I don't want to put in two parts and discuss, which is time consuming also. So as you know, the final answer has to be positive. So I just keep trying to get positive answer. So I don't want to care about the negative or what. Okay, now calculate the final speed of truck A. Final speed. Okay, so the information that we have is the mass, the UA, the UB. Okay, let us use principle of conservation of momentum. MA, UA, MB, UB, MA, VA, MB, VB. So MA 6,000. You can see the picture at the same time. The UA, right? Okay. 5.0 or negative 5.0. It's up to you. Like what I said, both will be correct. Okay. So let's say I put negative 5 first. Because it's to the left, I put negative 5. And then 5,000, 0, 6,000. VA is what we are looking for. MBVB, which is here, 27,000. This part is a bit confusing already. Okay, so in fact, when you put it here, you have to put negative 27,000. You know, this truck A collide with truck B, then truck B will move to the left. Move to the left will be negative. So you go and count the momentum. For sure you get negative 27,000. You won't get positive value. Okay? If you assume this direction to be negative. So you get negative 27,000. Because truck B is going to the left. So that's why negative 27,000. 27,000. So and then we count it. So you get negative 0.5. Negative 0.5 is reasonable because you know truck B moved to the left. So getting negative value is reasonable. But they ask for speed. So speed is scalar quantity. We just put the 0.5 only. No need the negative. So of course if you follow the blue color way, then everything will be seems to be very smooth. So if you follow the blue color, that means this way, takes 5. Then the working will be like this. 6, follow the blue color, 6,000, 5, 5,000, 0, 6,000, VB, sorry, VA. We are counting VA. Okay, it's a mistake. VA 27,000. So if you follow the blue color way, so everything seems like no problem at all. So you get 30,000 minus 27, 3,000, 6,000 VA equal to 0.5. So then it will be like that. Okay. So we settled this already.